Hey guys, it's me. I'm just here posting a little bit of an introduction to a little chemistry demo Mr. Sreda and I kind of did to show you guys some reaction rate stuff. So I'm going to post two of these little introduction videos for two different lessons. The first one we're going to look at is called the iodine clock. So where's the... there it is. It's chemicals we're going to use. We're going to take soluble starch. We're going to add to it some potassium iodide, some sodium thiosulfate, and we're also going to add, well, we didn't use ethanoic acid, we used hydrochloric acid, and hydrogen peroxide. So these chemicals are all going to mix together, go through a whole bunch of steps, but the idea is that some of these steps are fast, some of them are slow, and you can actually see the exact second due to an indicator reaction when this elapses. So I'll show you the video of that reaction afterwards. What we did is we kept our potassium iodide concentration the same, our sodium thiosulfate concentration the same, our acid concentration the same. The only thing we changed was our hydrogen peroxide. We added 5 milliliters to one, 10 to the second, and 15 to the third. The idea being if you add more of it, it's actually more concentrated in that solution. So we used the same actual, it was 6%, I believe, hydrogen peroxide, but we added different volumes, which basically just put more in and increased the raw concentration of it in the solution. So we'd be looking at how does the concentration of hydrogen peroxide affect the reaction rate. So procedures is just making all this stuff. Let's look at the teaching notes. These are actually pretty good. They recommend a white background just because there's a really spectacular color change. What happens is iodine, elemental iodine, I2, when it mixes with soluble starch, they bind together and turn dark blue, like basically black. And it's like a clear solution and then blue, like black blue. Similar to how the titration, it was like clear and then boom, it goes pink. Same idea, but this one goes basically black. So the basic reaction we're looking at here, if you look at all the steps put together, peroxide mixed with iodide, that's from the potassium iodide, combines with H plus from the acid and forms elemental iodine, and this is what's going to stick to the starch and cause the reaction, plus H2O. So the starch isn't actually in here because it's basically an indicator. It's not actually part of the reaction. It's just something that's going to stick to the iodine and change the color really drastically. So here's kind of what ends up happening, though. When we mix the peroxide with the potassium iodide and end up spitting out iodide molecules, it forms iodine. As soon as the iodine is formed, that's a slow step. It takes a while, like not a while, but it's the slowest step here. As iodine is formed, normally you'd think, like, oh, as soon as I make it, shouldn't that complex with the starch and turn black? Normally, yes, but we also added thiosulfate. If you look up at our list here, we also added this sodium thiosulfate. And that's not in the reaction here because it ends up basically just getting used up as a almost like an intermediate. But what it does is as the iodine is formed, the thiosulfate eats it. So the thiosulfate is turned into this crazy ion here, tetrathionate. I don't even know what that is. But it forms this tetrathionate ion and turns back into iodide. So it sends you back to the beginning of the reaction again. So this kind of cycles in a circle where this turns into iodine, iodine gets eaten and turned back into iodide, and you get stuck in this cycle. And this cycle lasts as long as it takes to eat all your thiosulfate. Once your thiosulfate is gone, once you've burned through all of it, then this iodine can't be converted anymore. Then the reaction happens and it turns black-blue. So this is a slow step. So as soon as this is done, so like slow, I've made some iodine, boom, it turns back into iodide. Slow, I make some iodine, boom, it turns back into iodide. And so you're really stuck on this particular step, the peroxide and the iodide, until you finally end up using this. So it's really good for timing. It's really easy to time. And, well, I'll show you why in just a second here. Where's my iodine clock? So this here's the 3%. Or sorry, 5 mils, 6 mils. Oh. See, this one's not reacting. No, this one is slowly going. This should be the most concentrated. This should be the fastest. We added it a little later, but keep an eye on it here. And full black. Now full black. See Mr. Shred's glorious chin. There you go. 5, 10, 15 milliliters. So you see this one, even though we added it later, still finished first. It was real fast. This one, even though we added it the same time as this one, it was like, it took a little while, but it reacted at a decent rate. This one took a long time to actually work its way through. And the only difference in all these solutions, it was all the same chemicals, all at the same concentration. The only difference was how much peroxide we added. By adding a little extra peroxide, you increase that concentration a bit. So we doubled the concentration, then tripled it. And you can see the massive change on the reaction rate as how fast it eats up that thiosulfate. Very fast. This was moderately fast, and this one actually took quite a while to do. So that's our iodine clock reaction. Is a really, there we go, a really classic example of a rate determining step, because you're stuck on this first step for a while until you can actually use up the thiosulfate, and then you see that dark black change right away. So thanks for watching, guys. I got one more video coming at you in just a second. Oh, before I go, one thing to notice, doing the lab, I had goggles on. I don't know if you could see it, but I also had gloves and safety coat. Always do safety first.